Welcome to Almost Here, Round the Corner Future Technology podcast with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more.
Hello, this is Richard Jacobs with the Future Tech Podcast. My guest today is Brian Curtis. He's the CEO of Concentric Power, and the website is concentricpower.com. So, Brian, thanks for coming. I appreciate it. And how are you doing today?
Doing well. Thanks for having me.
Yeah. So tell me about Concentric Power. What's the premise of the company?
Sure. Yeah. Concentric Power, we are building sustainable infrastructure for ag and industry applications. So what that really means for us is we've been focused on a lot of firm power applications, natural gas, gensets, battery storage, coupled with renewables. And one of the main goals is to be able to maximize sustainable energy in the form of renewables and everything that's required to support that as we get higher and higher penetrations in the grid and on-site applications.
Well, what do power sources look like right now? I'm an outsider, so I bet you most people assume it's like either all traditional or all renewable, and there's not much hybridization going on. But it sounds like that's what
Sure.
you're doing. So, what's the current state of things, and what do you want to do?
Yeah, so the current state of things is a lot of power is derived from the grid, and the grid is made up of all kinds of different energy sources depending on where you are. So if you're in California, we've actually gotten pretty far in terms of renewables. We're based here in California, and a lot of our projects are here. But different parts of the country has different energy mixes, and so the current state of things is kind of different depending on where you're at. I'll talk about California, a couple of case studies out here. We're working on a site, for example, that's got wind, solar, cogeneration, and soon batteries all at the same behind the meter location. This is a fresh vegetable processing facility here in Central Coast, California, and they've got as much solar as they can fit on the roof. They've got a big wind turbine out in the field. What we provided for that application is a natural gas engine to support all that. We can run 24/7, whereas obviously wind and solar is going to do what it's going to do in terms of when the sun is shining and wind is blowing. But we're able to provide the support for that, and we see that as a really big trend going forward, where more and more distributed energy resources are deployed closer to where the energy is actually being used. A lot of that's happening on the commercial and industrial side of things, but it's also happening a lot for residential and other sectors.
So what's some of the most interesting projects you've seen, and what do they look like?
Sure. Yeah. No, I think the most interesting stuff to me is when you start getting these hybrid solutions. I've always maintained that there's no one single answer to greenhouse gases or climate change or energy efficiency. There's lots of different technologies, and the interesting projects for me are projects where all of those technologies are coming together at the same place and trying to figure out how to coexist and get a site host or a site customer all the way there in terms of energy efficiency, sustainability, energy independence, and of course cost always matters. So being able to do all of this in a way that is economically interesting.
All right. So what's the benefits of this hybrid model of bringing power? Like, are there any trade-offs too? How is it better than just getting it from the grid?
Sure. Yeah. A lot of it has to do with being able to match a certain energy supply mix with what is required at a given site. So different sites have different energy profiles or load profiles, as we talk about it. Some sites have really spiky loads where you've got equipment or lights or things that are really going on and off pretty often. Others are pretty flat and smooth. So if you can come up with the right solution for a given application, you can get that much closer to an optimal solution. So being able to do that on a distributed energy basis helps you get there. There's also just on a macro level some benefits to the overall system where there's a lot of actual losses in transmission. So you lose some efficiency just by virtue of transmitting power around the grid. And then the flip side of that is the more and more renewables that are added to the grid, you've got a lot of power that's being pushed maybe in a way that the grid wasn't designed for originally, and you need firm power support to support that bigger effort.
It seems like with renewables, like solar, what do you do at night? Or wind, what do you do when there's no wind? Or geothermal, what if that seems constant, but again, it's only available in certain places. So when you're coupling in renewables with traditional power sources, I guess that's why you need battery systems, right? To reserve the power for when it's not there.
Yeah, that's right. So you basically nailed it. A lot of renewables, wind and solar in particular, are intermittent. They're not running 24/7. So you've got to figure out a way to support that energy storage, and I'll use that as a more broad term than just batteries, because there's other ways to store energy. For example, there's pumped hydro where you can work with the reservoir as a way to store energy. And there's other ways, thermal energy. If you've got different heat loads or chilling loads, you can store energy thermally. But yeah, at the end of the day, what's needed to get to 100% renewables is some form of storage, or alternatively other forms of firm power that can come from, for example, natural gas that can ultimately also be powered by renewable natural gas or biogas that can come from different renewable sources. So natural gas is a good stepping stone to get to 100% renewable.
What about harvesting waste energy from a large plant itself? Is it worth it to do that? If the operation's large enough, or is that not really a useful source of power?
No, it's definitely a useful source. In fact, a good chunk of what we do is taking advantage of that waste heat from the engines that we're running. So one of the kind of unique applications that we've been working on is for refrigeration. So food industry and cold chain sort of applications. So fresh vegetables, and then it also applies to meat and poultry and fish and all that kind of stuff. But basically what we do is take the waste heat from the engines that we're running, and we drive a refrigeration process, which sounds kind of counterintuitive. You've got heat to make cold, but there's pretty well understood technologies to do that in the form of absorption chillers that allow you to do that, and actually you can get to pretty low temperatures using that kind of technology. So that's something that we found is a good way to take full advantage of the thermal energy available at a site, and really drive efficiency as high as possible.
So where's the bottleneck right now? What's the weak link in the chain in these hybrid systems?
Yeah, the interesting technology aspect to it all that is really just coming into its own right now is the software and controls of these systems. So a lot of each of the components, many of them have been well proven over the years. Solar and wind are at this point mature technologies, as is cogeneration and natural gas engines. But being able to run all of these systems together in a coordinated ecosystem is not a trivial matter. And so and this is where I kind of geek out on all this, is the software and controls to run that. So at Concentric, we've developed a software platform that looks at the whole energy picture on an instantaneous basis, and then also learns, so using machine learning, artificial intelligence kind of thought processes, is doing pattern recognition and starting to teach itself how to run a system. So I'll give you an example. If you've got a manufacturing facility that has wind and solar and cogen that you can ramp up and down, as that underlying load of the facility ramps up and down, you can start to identify patterns and fingerprints of equipment, and so you can actually be predictive and one step ahead of where the energy load is going based on sort of a machine learning type approach. And then when you take that logic and then apply it across a whole network of facilities that have energy capacity that you can dispatch at a given time, all of a sudden you've got this really smart distributed system that can not only serve the load at a given site, but also dispatch that power into the grid. So there's a lot of really cool sort of advanced software technologies that are being applied to the grid at this stage.
What about pricing of the power? If you have a hybrid system, I would guess there's times where you want to draw from this source and not from that source, and various sources are efficient at different times and different conditions.
Right. Yeah. No, absolutely. There's the grid is a really dynamic thing, not just technically but economically. So different times of day, different times of year, the economics are all different. So that's part of the Concentric platform as well, is taking all those different price signals into account to say, okay, well, at this moment, given everything that we see and everything that we're predicting is about to happen, we might want to run differently in the middle of the night in the winter than we would in the middle of the day in the summertime. And then, of course, those economics are really different in different parts of the country, where you've got California, which is notoriously expensive power compared to other parts of the country where power is a lot cheaper. In some cases, the power is cheaper because there's a lot more coal, for example, on the grid in different parts of the country compared to California. So there's a sustainability factor to it in terms of what your goals are. Not just energy efficiency and economics, but also sustainability.
So is there anything missing in your models right now? Are you accounting again for cost of the power, of where the power needs to go, of the type of loads, spiky or flat? I mean, are you boiling all these things into your model with machine learning to get the optimum?
Right. Yeah. No, that's basically it. And it's I think really what's missing at this point is just a critical mass of smart generation and smart or intelligent even components that are all sort of feeding off each other. We're just barely getting there. We meaning as a collective grid, and Concentric, we're working on a lot of these technology solutions. But we're just I would say as a society, we're just barely getting started on what the next generation of the grid's going to look like.
Any metrics on how much more efficient or how much cheaper or how much this, that, or the other these hybrid systems are?
Sure. Yeah. In terms of efficiency, you can actually get some pretty dramatic efficiency improvements. You mentioned waste heat as an example. You can go from a natural gas engine that's considered high efficiency, is sort of 42 to 45% efficient, is considered a really high efficiency engine. But then when you take advantage of the waste heat, you can get basically, instead of dumping that heat and not using it, you can get up to 85, 90% efficiencies on the engine side of things. And then again, it's really location specific, but in terms of transmission losses, you can get up to 25, 30% efficiency losses through the grid if you're talking about a centralized power plant versus distributed energy. Those are some of the metrics there. In terms of cost, again, really location specific, but you can improve over the cost of the sort of standard utility by upwards of 50% or more, where you've got the cost of the equipment and building the sustainable infrastructure, add in some cost of capital for the project itself, but you're still beating the grid by a pretty fair margin.
Okay, yeah, I didn't realize the efficiency was so great. That's great.
Yeah.
All
No,
right.
there's a lot of low hanging fruit out there, and there's a lot of complex projects that maybe isn't quite as low hanging fruit, but if you've got the right framework and tools, the opportunities are huge.
So what's next for you over the next 6 months or a year? What kind of new projects are you working on?
Yeah, the big stuff that we've got right in front of us, a couple of big projects that we're not quite ready to announce, but they're really microgrid oriented, where we've got some industrial parks that are trying to attract some pretty energy intensive industries, and they're looking to do that in a sustainable way. And in some cases, they're required as part of the economic development to do it in a certain way. So we're building microgrid infrastructure that takes all of this into account, which is it's been fun for us because I would say most of our previous projects have been sort of retrofit for existing facilities that are already interconnected to the grid, and we're playing within that context. So a couple of these big projects that are coming our way are greenfield new projects building extensive microgrids that have max out renewables and energy efficiency, and doing it all in a way that promotes the economic development that the local communities are looking for, and doing it in a real sustainable way.
Well, very good. So what's the best way for people to reach out to you if they want to learn more and coordinate with you?
Yeah, the website's a great first start, concentricpower.com. And also there's our phone numbers on there that you can call, and we're pretty accessible. We're still a pretty nimble, accessible team, and we are growing. And actually for listeners out there that are interested in career stuff, we're hiring a ton right now. So if there's anyone interested there, please do reach out. We're hiring on engineering and project management, but obviously customers as well. We'd love to talk to you.
Okay. Well, very good. Well, I appreciate you coming on the podcast. Any other questions you wanted me to ask you, or you think we've covered everything?
No, I think that's a good coverage. Like I said, I think we're really at a beginning point of a new big phase for energy infrastructure in the country. So it's really a transitional time. We're excited to be part of it at Concentric, and some of the technologies that are going to be rolled out, not just the generation technologies themselves, but the software and controls, and how you do this and what the right business models are. It's going to be a really exciting time, I think.
Well, that's great. All right. Well, I appreciate you coming on. Thank you so much.
No problem. My pleasure.
You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.